So hello everyone. In this session I'll be explaining a very simple code which will count the total number of vowels in any given string. So what are all possible vowels that you can see in a string? They are A, E, I, O, U. So these are lowercase characters. If I write in uppercase, caps A, E, I, O, U. So the only intention of this particular code is to count how many number of vowels are available in any given string. Now let's see how exactly it is done. Okay. First let me check if there are any errors in this code. Okay. There are no errors, so we'll go ahead with debugging. Okay. So first of all, what is this area? Area is nothing but an assembler directive which will define a section of memory to store this particular instructions. Count vowels is the name I have given to this particular section of memory. Code is a property of assembler directive area which informs the assembler that the given information are nothing but instructions. Read only because we don't want any modification to be happening to this particular code. Entry assembler directive indicates where exactly execution starts. That is the very first label after entry is the position where execution starts. Start is a label. LDR R0, equal to str is a pseudo instruction which loads the address associated with the label str into register R0. And what is this label str? str is the label associated with my string hello world ARM7. DCB here indicates define constant byte. We have used DCB here because each character of this particular string will be stored in one location, or it occupies 1 byte of the memory. And the reason for that is strings are nothing but array of ASCII bytes. Okay. 0 here indicates the null character. That is a very common practice to end a string with a null character because we are considering a null terminated string. Align ensures there is no memory alignment issues here. End indicates the end of source file. Let's proceed with our actual execution. When I check for the address 38 in the memory, I can actually see my string here. If I click on ASCII, the actual text can be seen. I'll change it back to numeric data. So now in the next step, I'm storing R4 as 0. R4 is my counter which will store my final result. Let's initialize R4 with 0. So now what exactly happens here is R0 is nothing but a pointer. Okay, it will point at this particular location, to be specific, to the very first character of the string. Okay, 48 is nothing but ASCII value associated with capital letter H. So what exactly happens is this ASCII value is now stored into register R1 and R0 is incremented so that it can point to the very next character, that is here. Okay. And we are comparing if R1 is actually 0. Why are we doing this comparison? Because we want to check if we have already reached the end of the string. If we did reach, then all comparisons are done. Okay, we have to just check what value is stored in R4. If that is not the case, we have to perform our next set of steps to check if given character is a vowel or not. Let's continue here and let's proceed by executing that step. We have loaded ASCII of the first character into R1. We are comparing with 0, which will update the CPSR based on the result of subtraction between R1 and 0. If R1 is actually 0, then Z would be set. BEQ checks if Z is 1. If it is 1, it will branch to the label stop. Let's see what happens there. It's an infinite loop. Stop, branch to stop. Okay, it keeps looping here. But we have not reached the end of the string, because of which we have to now check whether given character is actually a vowel or not. Okay, if we check here, the very first thing we are performing is OR operation. Thing is, if we consider any lowercase character and compare its binary value to that of uppercase character, okay, lowercase character a has ASCII value 61 and uppercase a has ASCII value 41. So its binary value will be, only difference you notice is in the 5th bit position. It is set for lowercase and clear for uppercase. Okay, by performing this particular operation we are converting any given alphabet to lowercase, and if it is not an alphabet, even if this OR operation will update the ASCII to some other new ASCII value, they will get ignored here. So once we perform this particular OR operation, all characters are converted to lowercase. Reason is we don't want to perform 10 comparisons, that is one with lowercase, one with uppercase. We have converted everything to lowercase character, so we have to perform only 5 comparisons. Okay, so now let's see what exactly happens here. We compare if given character is actually A. By writing #A, we are comparing R1 content with ASCII of lowercase a. Okay, if this is actually true, comparison result will be 0. Okay, because internally subtraction happens and that will update Z flag. If that is not the case, like in our current case, our character we are considering is actually H, that is caps H, which gets converted to lowercase h in this particular step, but it is not any of these vowels. Okay, because of which all these comparisons will not affect the Z flag and hence this addition won't happen. That is because see, compare will update the CPSR conditional flags. If any of this leads to Z being equal to 1, this addition happens where R4 is incremented by 1. Okay, if that is not the case, in that particular case this addition won't happen, and if you notice here we'll be branching back to the loop. Okay, and one more thing is, let's assume here, okay, actually any one comparison generated Z as 1, all remaining comparisons will be ignored because NE here checks if not equal, that is if Z equal to 0 in the previous steps, only then perform this comparison. If Z was actually 1 in one of the steps, the next steps will be ignored. So that's the main logic that works here. Let's see that happening. So in the first case, obviously R1 is not 0, so we will not branch, this is ignored, but OR operation is performed to convert uppercase h to lowercase h because 68 is ASCII of lowercase h. So now we perform the actual comparison. Okay, we'll check if it is equivalent to A, E, I, O or U. Okay, as you can see, any of these operations will not set Z as 1, because of which this addition is also ignored and we branch back to loop. What about the next character? Let me change it to the actual text. You can see next character is E, so obviously what should happen? This particular comparison, that is CMP and E with E, will generate Z as 1. Let's see that happening. You can see Z is 1, because of which this particular addition happens and R4 is incremented, and then we branch back to the loop, and this will continue until we reach the end of the string, that is until null character is detected. So let's see all that happening. Since even the last character is already loaded, the next character which will be loaded will be the null character. You can see 0 in R1, because of which this comparison will set Z as 1 and hence will be branching to stop. Okay, so stop is an infinite loop. It will be stuck here in this particular loop. And now if I check what value is stored in R4, it is 4. Let's check if the total number of vowels in this particular string is 4 or not. You can see E here, O here, O and A. So as expected, the generated answer is also 4 and total number of vowels in this particular string is also 4.